so we have talked about the chemical nature of water and its polarity. Now we're going to see what that polarity means for how water actually behaves on Earth and within and around living things. Okay, so remember, please, that all of water's properties are derived from its polarity. If water weren't polar, none of the rest of this would be so. Okay? Now, the first thing we need to remember about water's first property, so this is number one, is that water is cohesive. What does that mean? That simply means that water tends to stick to itself. Okay? Examples of this are surface tension. This little water strider is taking advantage of surface tension. He is so light and his little legs are designed such that he can walk on the surface of the water without breaking the water tension, without breaking really the hydrogen bonds that are connecting different water molecules to each other. So he is so adapted to this environment that he can walk on that water without breaking those little weak hydrogen bonds. Okay? Another thing that is important is this helps with pulling water up roots in plants, and we'll talk about that perhaps later on in the year. All right, water's second property, number two, is that water is adhesive. Okay? What that means is that water tends to stick to other things as long as those other things are also polar or charged electrically. So in other words, just like, you know, my eraser won't stick to my chalkboard, you know, all by itself. I have to stick a magnet in there and that will stick to the magnetized chalkboard. Water won't just stick to any old thing, but it will stick to things that are also attractive, that are polar. Okay? Examples. Okay? Capillary action. Capillaries are tiny tubes. You have capillary carrying blood throughout your body. They're tiny tubes. Water will rise up a tiny tube for no reason other than it likes to stick to the sides of the tube. Now, would it rise up a nonpolar tube? No. But if the tube is polar, as most glass substances, for example, are, it will rise up the tube. Now, the more narrow the tube, the higher it will go. But that same principle is what carries liquids up into a paper towel, for example. There's all these little tiny pathways. The fibers of the paper towel are polar, and the water just runs up these little tunnels and tubes and pathways up into the paper towel. Even this leaky basement, there are all the little pores and tubes and so on of the concrete. The water just meanders up into that because of water's attraction for the cinder block. Okay? Now, again, this is another thing that also aids in pulling water up plants from the roots, and we'll talk again more about this when we get to plants. Okay? So those are two properties: adhesion, cohesion. Not necessarily in that order. We did cohesion first. Okay? Another very important property of water is its high specific heat. So this is property 3. Okay? Specific heat is a chemistry term, but all it is the amount of energy that it takes to raise the temperature of a gram of water or any other substance by a degree Celsius. So how much heat does it take to jack that temperature up by 1 degree? Okay? Now, water has a really high specific heat. So what does that mean? That means it takes a lot of energy compared to some other substances to raise the temperature of water by 1 degree. If we had alcohol, some rubbing alcohol, and we put it on a Bunsen burner, within very little time it would just go poof and explode. It doesn't take hardly any heat to to heat up something like that. But water, it takes rather a lot of heat to make it change its temperature. Okay? what this means for living things and for planet Earth. Water can store lots of heat. It can take in lots of heat without changing its temperature very much. So it can store lots and lots of heat. Okay? Why can it store so much heat? Well, because when you're applying heat, the sun is shining on the ocean or whatever, it takes a lot of energy to even remember, molecules start moving, and that's why we feel heat. Well, to get that to happen, we have to break those hydrogen bonds first. The molecules are kind of stuck together. So it takes a lot of energy just to break those hydrogen bonds, and then those molecules can move and we feel the temperature go up. So it takes a lot of energy to break those little hydrogen bonds, and that's why it can absorb so very much heat. All right? Now, why is this important for life? Here is why it's important for life. Because the temperature of the temperature of water is so stable because of its high specific heat. Our body temperature, because our bodies are mostly water, and the temperature of the earth, because the earth has mostly water covering it, tend to be very stable. We don't get wild fluctuations like maybe on Mars or the moon or something like that, because water makes our temperature very stable. Okay? Water, number 4, has a high heat of vaporization. Now, what is a heat of vaporization? It is simply the amount of heat it takes to vaporize a gram of water. So we're making a gram of water, liquid form, go into a gas. And it's how much heat it takes to do that. Water has a really high heat of vaporization. What that means is it takes a whole lot of energy to get a gram of water to go from liquid to gas. Water does not evaporate easily. Okay? Again, think of the rubbing alcohol. If we put rubbing alcohol in this pot, boom, it's going to change temperature very fast, and it's going to turn to vapor really fast. Water, not so much. You know how long it takes for this pot of water to come to a boil. It takes a lot of intense heat to get the temperature up, and then finally to make these little molecules shoot off and separate themselves from the liquid state. Okay? Why is this important for life on Earth? That's what we really want to know here. Well, first of all, it allows us to retain our oceans and so on. They didn't just evaporate into outer space billions of years ago. We have them still because it's hard to vaporize water, hard to make it evaporate. Now, for you in particular, as a living thing, it is excellent to cool you off. It is good for what is called evaporative cooling. You sweat not because having a bunch of water on your skin makes you cool. Water on your skin not going anywhere does not make you feel cool. But when the water evaporates, when this guy, a water molecule absorbs enough heat from this guy's body to finally go poing, whoops, poing, off into the air and become vapor. It takes all the heat it took to break those hydrogen bonds and get that guy airborne. It takes all that heat with it. And that's what makes him feel cooler. Okay? So it's the evaporation that helps make you feel cooler. Okay? So that's another important property of water. It has a high heat of vaporization. It takes a lot of heat energy with it when it vaporizes. Okay? Ice floats, property 5. Really interesting property of water. I mean, if you had a solid, some liquid aluminum and a solid block of aluminum, okay? You drop that aluminum solid in the liquid and it's going to sink. Why? Because solids are packed more tightly, they are more dense than liquids. And so they will sink in a liquid even if it's the same substance. Water is not like that, okay? Because of the hydrogen bonds, and we don't really need to understand the chemistry of it, but molecules will get more densely packed together to a point as they get colder. But because of the way the hydrogen bonds interact, at right near freezing, they go poing, and they bounce just a little bit apart, those water molecules. And that makes Solid ice, when you have a glass of nice water and you put an ice cube in, that ice floats in the water because it is less dense than the liquid water is, okay? Why do we care in terms of life on Earth? Hugely important for life on Earth, which is certainly started in water, okay? Ponds and all other bodies of water do not freeze solid, okay? Usually. If you have a really shallow body of water, then maybe so. But a typical pond, or certainly an ocean, ice forms a layer and it lays on top because it floats, okay? If it did not, if this is your pond and that's your water, the cold air hits that pond, it freezes, and if it's a typical solid, it sinks to the bottom, the next layer freezes, sinks to the bottom, the next thing you know, you've got solid ice all through your pond. This sits on top. This ice sits on top of this pond and protects the water underneath from this nasty cold air above and keeps the underneath liquid at a suitable temperature to support the life underneath, okay? To keep it from dying and freezing to, or freezing, simply freezing to death. All right? Next, I think this is number 6. Water is a great solvent. It is a great solvent as long as the solute, the thing that's going to be dissolved, is charged or at least polar. Okay? In fact, water has been called the universal solvent. All right? Think about salt water. You take some salt, dump it in some water, very quickly the salt will dissolve. Okay? That's because, remember, sodium chloride, this is a positive ion, this is a negative ion. Well, the negative, slightly negative oxygens will be attracted to this sodium, but the slightly attractive hydrogens of water will be attracted to this chlorine, and the next thing you know, the water molecules are surrounding the chlorine ion, and the water molecules, but their opposite ends, are surrounding the sodium ion, and we've separated them. They've become dissolved, okay? So, as long as a substance is polar or charged, water will gladly get in there, mingle with it, and break it apart and dissolve it. It is a great, great solvent of many things. Finally, number 7. Water tends to organize or separate nonpolar substances, substances that are not charged or not polar, okay? So, water would rather cling to itself than to any nonpolar substance. Again, think of magnets. They would way rather cling to each other than to a wooden table that is not magnetized, okay? So, what water does then, this is oil. Oil is not polar. It is a non-polar substance. Water is not interested in sticking to that oil. Water would way rather stick to itself than stick to that oil that has no little opposite charged things happening to it, okay? And so, as everyone knows who's ever had oil and vinegar salad dressing, the oil and water don't mix. The oil will sit on top, okay? That's right, isn't it? Anyway, they separate. Why do we care? Hugely important for the formation of the very foundational part of cells, the cell membranes. Cell membranes are able to form because of water wanting to separate from nonpolar things. And when we learn about cell membranes, which is what is being illustrated in this little diagram here, we'll learn all about that. But just leave it at that for now, okay? That's it. So those are the 7 properties of water: cohesion, adhesion, high specific heat, high heat of vaporization, ice floats, great solvent, organizes nonpolar molecules. I will see you in class. Thanks for watching. Take care.